Assalamu alaikum. We're going to continue with lecture 7. We'll finish it today, inshallah. Okay, so just a quick review of what we did last time. Here's what we have. So we said we have three-phase circuits or systems. And this is basically a source that is three-phase. So 3 pH is phase here. And this is source. And we talked about the source last time. And we have three-phase load. Between them, you have 3 wires. And those wires, we call them the transmission lines. Okay, so those are the lines that take the power from the source to the load. Sometimes there is fourth wire called the neutral. Okay, this is not all the time, okay, neutral. Now the current in here is the line current A, the line current B, the line current C. If the system is balanced, the sum of the 3 currents is 0, so the neutral current here will be 0. So what happens, this is the load, the 3 currents coming, and the neutral current is leaving. So the neutral current equals to the sum of the coming currents, IA plus IB plus IC, because there are 3 currents coming. Those are called the line currents, okay, going through the transmission line. Those 3 currents, if they're balanced, one will be like this way, one will be like this way, one will be like this way with phase angle 120 between them, so the sum of them will be 0. So in balanced system, the sum of the line currents is 0. The sum of the voltages phase is 0, the 3. Phase 1, phase 2, phase 3. Okay. The line is the same thing. So V line 1, V line 2, V line 3. If you add them, they're going to be 0 because always they're the same magnitude and they have phase shift between them 120 degrees. So they cancel out each other. Anyhow, so we said 3-phase system means 3-phase source and 3-phase load. Now, we did after that, we talk about the 3-phase sources. We said this means 3 sources, single phase sources, either connected Y like this, or they're connected delta like this. So those are sources. Now, when they're connected Y, the polarity is like that. So now they're not DC, but still we consider the polarity. Okay, they're AC sources. So there is current leaving this way, current going through this out, and current going through this out. Now here, polarity would be positive, negative, positive, negative, and positive, negative. So this is the point A. This is B. This is C. This is A. This is B. This is C. And there is phase current going through this source like this. And there is current going here. Look at the polarity of the voltage source, and this is like this. So this is I phase, the first one. This is I phase here, the second one. This is the third one. The same here, this is the phase, so it's inside. And this is the phase, and this is the phase. Then there is the voltage, phase voltage. V phase. There's another one here. V phase. Okay. Then there is a third one here. V phase. Now we get into current in here is the line current, I line. Okay. Going in the line, not in the phase. I line. And here it's I line. Then the same here in the transmission line here, we call it I line. And here we call it I line. And here we call it I line. Is this okay so far? Y connection, delta connection. Okay. Now, what we learned last time that the I phase here is gonna equal to the I line. The current in the phase, this current, is gonna equal to the current in the line because this is single branch here. What goes through the source is gonna go through the line. So we learned this last time. Here, the voltage between line to line, this is the voltage between line to line, is gonna be the same as the voltage between phase to phase, which is this voltage. V phase. Because this point is the same as this point, is the same as this point. And the other side here, this equals to this point and this point, the same point, basically, there's no thing. So from here, V line equals V phase. So once you look at Y, you can see clearly the current going through the phase is the current going through the line. Now, three phase means three phases. This is phase one. This is phase one. This is phase two. This is phase three. So the current going through the phase, we call it phase current. The voltage across the phase, we call it phase voltage. Same here. This is phase one, two, three. Three phases connected together, either in Y or delta. What goes through the phase, we call it phase current. What is across the phase, we call it phase voltage. Then we have the line. What goes in the line, we call it line current. What is between the lines, we call it the line voltage. Now here, the line voltage does not equal to the phase, because this point is connected to one phase, this is connected to another phase. Last time we said V line here, it's gonna be square root of 3 V phase. And when we do the angle, we're gonna get plus 30 degrees. Here, I line is not gonna be the current in the line here. It's not the same as the phase current because there is a node here, there is an intersection. So it's gonna be square root of 3 times I phase, and the angle is the opposite, so you're going to put minus 30 degree here. Those are the two important relationships for the Y connection and for the delta connection. Something to remember, when you draw Y, this is the Y connection and this is the line. So what goes in, the current goes in the phase is going to go in the line. So this gives you this one. So it's not difficult to figure it out. Just draw Y and see the phase current and the line current, they're equal. You don't need to memorize this. And the other one is equal, the other one is the line is bigger than the phase by 3. And when you do the delta, this is delta, and you can see the line voltage and the same voltage which is between this and this is the phase, they're equal. So this is why you have this here. Is this okay so far? Any questions? I heard you guys have a midterm tomorrow. Good luck with that. Any questions? No? Easy? Difficult? I'm talking to myself. Okay, so now if we know this, this is very helpful for the rest of the semester. Okay, those basics are very important for the rest of the semester. Then we learned last time, we learned something else we called the sequence, called phase sequence. So what is the phase sequence? Because I have 3 phases. Okay, each phase has voltage. This is VA. Then 120 degree after it, there comes VB. Then 120 after it, it comes VC. Then this is A again, this is B, this is C, then you're going to see A again. This sequence is called ABC, positive sequence. It means A first, then B starts, then C starts, then A again. Or you can look at the peaks, the maximum. A, then you see B, then you see C, then you see A, B, C, and continues like that. Then there is another sequence which is the negative sequence, which is basically having A, then what comes after is actually B, not B, it's C. So this is VA, this is VC, then after that comes VB. This is called negative sequence. So it's A, C, B. So the angle of theta for A, then minus 120 for B, then you go for C here, then plus 120. This is what we did. And I think if you know this, you're good with this lecture. I'm gonna do a few things, 4 exercises, then I'll let you go. So if we finish early, it's okay today. So I'm gonna share the lecture with you guys. Just wait. Okay, so stop share this and share the lecture. Okay, lecture 7. So we finished the lecture. This is the 3 phases, and the generator is going to give you the 3 phases. Those are 3 waves, and you can see the sequence here. Okay, A first, then behind it B, then C, A, then B, then C, then A, then B, then C. This is a positive sequence. The sum of the 3 is going to be 0 because they have the phase shift between them is 120. Then we went to the waves again. We said that this is a better system, then positive and negative sequence. We did the exercise and we did talk about the two connections, Y and delta. And we said this is the phase and the line currents, and you can see them here. What's inside the phase is called phase. So the current inside here is called the phase current. The voltage across this is called the phase voltage. What is in the line is called the line current. Between lines is called the line voltages. For Y or delta, this is delta connection. This is the Y connection. What's across here is called the phase voltage. What is going here is called the phase current. And we can see in Y, phase current equals to the line current. And in delta, the phase voltage equals to the line voltage because these are connected like this. Then we did actually talk about this thing. And we stopped. We're going to do the exercises here. Okay. Now, what connection is this? Y or delta?
Y connection.
Yes. So this is a source that has Y connected. And they tell you the sequence is A, B, C. So the angles A and B and C. Now let's look at A. It's the voltage VA is 120 angle 0. B should be 120 with angle. They give you theta 2 here. They don't give you this angle. Then C, they give you 120 and angle here, 3. They say, what is this angle? What it should be? This is 0. This is behind it by 120, so it should be what?
Minus 120.
Minus, so this should be minus 120. And then this should be minus 240, or you can write it as 120. So basically, theta 2 should be minus 120. Theta 3 should be plus 120. We usually write it not minus 240, we just write it plus 120. Then it says find the magnitude of the line voltages. So this is Y connection. In the Y connection, the line voltages, I'm going to erase this. In Y connection, we know that the line voltage, so line voltage equals to the square root of 3 V for phase, and we're going to add 30 degree. So if I want the first line voltage, VAB, I'm going to take the first voltage 120 and angle 0. I'm going to multiply it by square root of 3 and I'm going to add 30 degree. So this will be 208 and angle 30 volt. So you take the phase voltage, you multiply it by square root of 3 and you add 30 to the angle. This is the line voltage, which is here, it says EAB, so I'm going to just use the same labels they have, E between A and B. Which is between the line A and the line B here. Where is B? Okay, those are opposite. This is actually C and this is B. Okay, then we're gonna find E. Those are the three lines, E, B, C. It's gonna be the same, 208 And ECA is going to be the same, 208. Just 120 multiplied by square root of 3. Then the angle, this was minus 120 plus 30, so it's minus 90. Then this is 120 plus 30 is 150. Another way to do the angles, now magnitude is always the same. So if you have the first voltage, you can find the other ones the same. The magnitude, you can follow the sequence because it's A, B, C. So you do minus 120 plus 120. So 30 minus 120 is minus 90. 30 plus 120 is 150. Now the question doesn't say find the three values, it says find the magnitude. So VL, the magnitude only, is 208 volt. Because it says find the magnitude, not with the angle. But this is detailed answer, and this is what they actually want. Okay, I give you a minute so you can actually copy this down or take a screenshot. Okay, now I'll continue. Another example here. So they give you the phase voltages of Y connected source. Those are the phase voltages. Okay. Now what sequence is this?
Negative.
Negative sequence. Because 0 minus 120, this is A. When we subtract 120, gives me C. So this sequence is like this. VA, VC, then VB. The sequence is like that. So what we have, 120 angle 0, 120 minus 120, and 120 and plus 120. This is the sequence. Now, if I want the line voltages, I can do VAC, VCB, then VBA. So I can do VAC. I'm going to go through the sequence between A and C, between C and B, between B and A. Then VCB, then VBA. What I'm going to do, I take 120 multiplied by square root of 3, so 208, 208, and 208. Then the angles, I'm going to add 30 to each one, so 30 minus 90 and 150. Volt, volt, volt. What if someone says instead of finding VBA, find VAB? What would be VAB in this case? The same magnitude. The angle will be 360 minus this angle. Or this angle minus 360, both are fine. Because this VAB goes 150 degree like this. This is 150. The opposite will be like this. Okay, will be like this. It's this angle, not 360, 180, sorry. So this angle is minus 30. If I want BC, for example, the opposite, the same magnitude, and you're gonna add 180 or subtract 180, the opposite direction. So 90 minus 90 is going down, the opposite will be going up, so 90 degree. If I want ACA, the opposite, if I want that, but those are line voltages, it doesn't matter, this these ones are okay. 208, and the angle 30 is this. The opposite will be this way, which is minus 150 units, volt, volt, and volt. Is this okay or confusing? Now, the last thing it says draw the phasors. So if I take the phasors for these three guys, this is angle 30, so we'll make 30 degree. Okay, let me just put different colors here. So these are the axes. So this is VAC, makes 30 degree. Then the other ones, this is minus 90, so it goes like this. And this is VCB. And this is VBA, and make 150, so it's this way. This is VBA. So when you draw them, this is the angle 150, and this is the angle minus 90, which is 90, but in the negative direction. So this is the answer for this question. You can copy it, okay? We still have 2 exercises. Hopefully we'll do them in 10 minutes, then I'll let you go. Okay, we'll continue. This is just delta. This is one exercise. Now it says delta connected source. So this is delta connected source. I'm gonna do delta connected source. The voltage, let's say this is A, this is B, this is C, the voltage VAB, the voltage in this source 120 angle 0. Then the voltage BC is 120 minus 120. And this is 120 angle 120. The polarity is positive toward A because it's VAB. This is the polarity is toward B because it's BC. Then the polarity is C because it's CA. C is the positive, A is the negative. Okay. Now, is this phase sequence positive or negative? It's positive because angle 0 minus 120 and then plus 120. So B comes after. Now, find the phase voltages. Those are the phase voltages. Oh, those are the line, giving the line voltages. Sorry, they give you the line voltage here. They give you the voltage between this point and this point, V line. But in delta, V line equals to V phase anyway. So basically, if it says find the phase voltages, it's the same, these voltages. So the phase voltages, let's say that AB, then BC, and CA. Across the phases is exactly the same like those values. 120 angle 0, 120 angle 0, minus 120, and 120 plus 120. So in delta connection, the line voltage equals to the phase voltage between line to line is exactly a phase. Draw the phasor diagram. So you're just gonna draw the phasors for these ones. 120 angle 0, so that is this one. Then 120 minus 120, that is the second one. And the third one will be like this. This is VAB. And this is VBC. And this is VCA. The angle here is 120 positive. The angle here is minus 120, which is 120 in the negative direction. And this is the phasors here. Any questions? Okay, so the last question, which is this one here, they give you, it's delta connection, they give you the phase currents. Someone has the mic on. Hey guys, your mic. I had to mute you before you actually say something, I don't know. So phase currents in delta connection source. So this is the delta connection source. I'm gonna do the delta connection source. It might be very helpful to actually draw. This is delta connect source. This is A, this is B, this is C. So polarity is like this, polarity toward the B, and this is the polarity toward the C. There are three currents given phase currents, so they're inside the phase. One current going this way from B to A, and it's 6 angle 0. Then there is current going from C to B, so it's going this way inside the phase, and it's 6 angle minus 120. And the third one going this way, and it's 6 angle 120 ampere. Those are the phase currents inside the phases. They say find the line current, so the current here in this line, let's say IA, and the one here, let's see, IB. The one here, it is IC. So we know in delta, the phase current and the line currents are not the same. The one in the phase, when it comes to this point, some of it will go that way, some will go this way. So it's not the same. The phase is not the same as the line. And we know if they're not the same, the line is bigger by square root of 3. And there is an angle of minus 30. So if I want the line currents, the current A, the current B, and the current C, those are the three line currents. So what I'm going to do, I'm going to take the 6 multiplied by square root of 3. Okay, so 6 square root of 3 multiplied by the magnitude, which is 6. And the angle, which is 0, I'm going to subtract 3 from it, because 0 for the first one. So this gives me 10.39 and angle minus 30 ampere. Okay. Now the other ones, right away, you know what they are. The magnitude is going to be the same because it's balanced system. And even if you take the 6 here times square root of 3, 6 here times square root of 3, it's going to be the same thing. And the angles, you can just look at this angle, minus 120, so it's going to be minus 30, so it's minus 150. Because this is what it says the rule here. You subtract 30 degrees from the angle. And 120 minus 30 is going to be 90 here. Ampere. This is one way, which is using this concept that we got from before. Or there is another way, use Kirchhoff's current law, which is longer, but it's the same thing. You come to the node A. This node here. The coming currents to the node is the 6 angle 0. This is coming to the node. Leaving, IA is leaving the node. You can see it's going away. This is coming, and this is leaving. So this one, the other one is leaving, is 6 angle 120. So from here, IA will equal to 6 angle 0 minus 6 angle 120. And if you put this in your calculator, you're going to get the same answer, 10.39 minus 30 ampere. And once you find the first one, the other ones is just the same magnitude because the system is balanced. So you know they're 10.39, 10.39. And because the sequence is positive sequence, so you take minus 30, minus 120, you get minus 150. Then minus 30, the first phase, plus 120, you get 90 ampere and ampere. So two ways to do this, either using the quick formula. So you take the line current is square root of 3 of the phase current. They're not the same in delta connection. Or you can go to the node, every node, or one node at least, and you say the entering currents equals to the leaving currents. I know two currents and I don't know the third one. From the equation I can solve, I find it. Then once you have one line current, the other line currents are equal in magnitude and with the phase shift of 120. The first one is minus 120, the second one is plus 120 degree. This is the end. Any questions? Yes? No? Okay, so we have a class tomorrow. Yes, and it's gonna be for you guys 2 classes in the morning. 2 classes in the morning, and we're gonna finish in these 2 classes lecture 8 completely. So be there. Lecture 8 is a key for 9 and 10. It's important. It's not difficult, but it's not easy. Best of luck tomorrow, inshallah.